Welcome to this Schooling Online production. In this lesson, we will cover working scientifically skills. In this first lesson, we will focus on assessing the validity of primary data by looking at the independent, dependent and controlled variables of an experiment. While the second lesson will look at designing a valid experiment and the use of control studies. This is addressed in the HSC Physics syllabus content below. After looking at accuracy and reliability, the final component that we need to consider in science experiments is validity. Validity refers to how well an experimental procedure tests the aim and hypothesis of the experiment. In other words, does our method actually find what we set out to find? A valid experiment is one with proper treatment of the independent, dependent, and controlled variables. If you remember from Year 10 science, the independent variable is what we change in our experiment. The dependent variable is what we measure, and the controlled variables are what we keep the same across all trials. Remember, the aim of a science experiment is to see how changing the independent variable affects the dependent variable. If our experiment is valid, then we can draw meaningful conclusions about the effect of changing the independent variable on the dependent variable. If our experiment is invalid, then we cannot make a formal conclusion because other variables may have affected the results. Let's return to our archery competition from the previous videos, where the contest is drawing to a close. The aim of this competition is to measure each archer's skill with a longbow and identify the best archer. Therefore, the independent variable is the archer, which is a different person in every round. The dependent variable is each archer's score after they fire 3 shots. All other variables should be kept controlled to ensure that the competition is fair. Our last competitor is Chelsea the cheater. In case her name didn't give it away, Chelsea the cheater doesn't always play fair. Let's see how she goes. All 3 of her arrows hit the bullseye. It looks like she's actually a pretty good shot. Maybe she's as accurate and reliable as Robin Hood. Wait, what's this? Chelsea the cheater was using a crossbow? That's not fair at all. The rulebook clearly states that only longbows are allowed. By using a crossbow, Chelsea has introduced a new type of bow into the competition. This breaks the rules, as the type of bow is meant to be the same for each archer. We could conclude that she's pretty good with a crossbow, but we have no idea how well she can fire a longbow. And let's be honest, aiming a crossbow is much easier. Therefore, we cannot conclude who is the best at aiming with a longbow because Chelsea didn't perform the exact same test. To avoid similar issues in our science experiments, we need to pay close attention to the independent, dependent and controlled variables. This will allow us to draw valid conclusions from our data. Let's go through each of these variables in more detail and see how they relate to validity. Let's start by looking at the independent variable. The independent variable is the factor that we manipulate or change in an experiment. An experiment tests how the independent variable affects the dependent variable. For an experiment to be valid, we should only change one factor at a time. That way, we can conclude that any differences in our results are solely due to the changes in the independent variable and not other factors. Remember, the aim of the archery competition is to find who is the best at shooting arrows with a longbow. The independent variable is the archer, whether it be Robin Hood, Too Tall Trevor, or someone else. In each round, we test a different archer. But when it was Chelsea the cheater's turn, she introduced another changing variable, the type of bow. This means that 2 factors were changed, the archer and the type of bow. We cannot attribute her good score to just her archery skill, as using the crossbow may have contributed in some way. Therefore, the results from her round are invalid. Let's see how this applies to physics. Suppose we perform an experiment to determine whether adding more rubber bands to a slingshot increases its range. Firstly, Anna takes a slingshot, a small pebble and one rubber band. She pulls the rubber band back, aims horizontally, and releases it. Then she measures the distance between the slingshot and where the pebble landed. Anna repeats the experiment, but this time she uses 4 rubber bands. Surely this will make the pebble travel further. She stretches it back as far as she can and launches it horizontally. But to her dismay, the pebble travelled the same distance as before. Why did this occur? To help explain her results, let's identify the variables in this experiment. Since Anna changed the number of rubber bands in the slingshot, this is the independent variable. The dependent variable is the range of the pebble, since this is what Anna measured. All other variables should have remained constant. But Anna forgot an important detail. If we go back in time to the first trial, we'd see that Anna stretched the rubber band a distance of 14 centimetres. When she repeated the experiment with 4 rubber bands, it was much harder to pull them back, so she only stretched them by 7 centimetres. Therefore, the distance that the rubber bands stretched changed throughout the experiment. When Anna interprets the results, she could say that adding more rubber bands to the slingshot did not affect the range of the pebble. However, she cannot be certain about this conclusion, since she has another changing variable. She could say that decreasing the distance that the rubber bands stretched does not affect the range of the pebble. Neither of these conclusions make sense. So, what happened? Since we actually have 2 independent variables, the number of rubber bands and the distance they were stretched, we cannot determine how changing each one affects the results. In fact, it is likely that the range of the pebble increased when we added more rubber bands. This may have been counteracted by pulling the rubber band back a shorter distance, which would have decreased its range, leading to a null result. The correct conclusion to this experiment is that the combined increase in the number of rubber bands and the decrease in the distance they were stretched did not affect the range of the pebble. This conclusion does not address the aim of our experiment. Our aim focuses on the number of rubber bands, but our conclusion mentions something unrelated, the distance they were stretched. This is why we can only have one independent variable in an experiment. We want to make sure that any change in the dependent variable can be solely attributed to changes in a single variable. Now, let's look at the dependent variable. The dependent variable is the factor that we measure in an experiment. Remember, an experiment tests how the independent variable affects the dependent variable. Usually, there is only one dependent variable in an experiment, but sometimes it is helpful to have 2 or more dependent variables. For an experiment to be valid, we need to make sure that we are actually measuring the dependent variable and not some other factor. Sometimes there are many different factors that we can measure to achieve our experimental aim, so we need to pick the most appropriate one for each experiment. Let's apply this to the archery competition. We are trying to find who is the best archer, and one way we can measure this is by having each archer fire 3 arrows at a target and finding their total score. A bullseye could be worth 10 points, and the outer rings would be worth less. However, there are other ways to identify the best archer. We could also replace each target with a boy balancing an apple on his head. Each archer would fire 3 arrows, and for each apple they hit, they would get 10 points. In this scenario, it is much harder to score points, but we are still testing the skill of each archer because they must land their arrows in a small area. So this would be a valid test, even if it doesn't pass the safety assessment. But what if we try measuring the speed of each person's arrows using a radar gun? The speed of an arrow has nothing to do with an archer's aim, so it isn't a good indication of each archer's shooting skills. The results of such an experiment would be invalid because we've measured something that does not address the aim of the experiment. Let's return to our experiment involving the slingshot. Remember, the aim was to determine whether adding more rubber bands to a slingshot increases its range. To achieve this, we measured the distance from where the pebble was launched to where it first hit the ground. This is valid since we directly measured the range of the pebble. As it turns out, there are other ways to determine its range. For example, we could measure the initial velocity of the pebble using a slow-motion camera and video software. This is the velocity of the pebble when it first leaves the slingshot. From this, we can perform calculations to determine the range of the pebble. This is also valid because launching the pebble with a greater initial speed will increase its range, provided that it is launched at the same angle. Therefore, we can change the experimental method to use a different dependent variable and still obtain valid results. Another student, Sakura, suggests that we measure the pebble's time of flight, which is the time it spends travelling through the air. She reasons that if the pebble is launched at a greater speed, then it will travel through the air for longer and its range will be greater. But Sakura has forgotten an important detail. Since the pebble is launched horizontally, the time of flight only depends on its height above the ground. In fact, if she was to drop one pebble and launch another pebble horizontally, she would find that both objects hit the ground at exactly the same time. Do you know why this occurs? Well, we can start by analysing the motion of the pebbles in the vertical direction. Both pebbles accelerate downwards due to gravity, and when they are released, they both have a vertical velocity of 0. Therefore, they both fall downwards at the same rate and land at the same time. As we can see, both pebbles behave the same way in the vertical direction. Even though one pebble is launched horizontally and the other isn't, we can ignore these facts when analysing their motions in the vertical direction. Remember, the vertical and horizontal directions are independent, so what happens in the horizontal direction stays in the horizontal direction. Now, this has a pretty big impact on our experiment. Regardless of how fast we launch the pebble, it will always land after the same amount of time. Therefore, there is no relationship between the pebble's range and time of flight, and this is not a valid dependent variable. As you can see, we should carefully select the variables that we measure in an experiment, as some factors are unsuitable and will give us invalid results. Let's move on and discuss controlled variables. A controlled variable is a factor that is kept constant in an experiment. Remember, for an experiment to be valid, we should only change one factor at a time. When we change the independent variable to see its effect on the dependent variable, we should keep all the other factors that could influence the dependent variable constant. If some other factor is allowed to change, even by a little bit, then the results cannot be solely explained by the independent variable, and the validity of the experiment is reduced. Therefore, in most experiments, there are many controlled variables. The number varies depending on the experiment being performed, but in general, you should try to identify as many controlled variables as possible when designing an experiment. For example, the archery competition runs according to a set of rules. These rules ensure that everything is kept constant between rounds, except for the archer, of course. Let's read through them. The first rule specifies that all bullseyes are the same size and shape. If we increased the size of the bullseye for one archer, then it would require less skill to aim at. On the other hand, If we change the shape of the bullseye from a circle to a rhombus for one archer, it would require more skill to hit. So we need to keep the shape and size of the bullseye constant between archers. Otherwise, we can't draw meaningful conclusions about each archer's ability to aim. The second rule states that only longbows are allowed. As we saw with Chelsea the cheetah, it requires less skill to aim with a crossbow than a longbow. Therefore, each archer needs to use the same type of bow, or we can't make fair judgments about each archer's ability to hit the bullseye. The third rule says that competitions are not held on windy or rainy days. Rain causes arrows to slip off bowstrings and obscure competitors' vision, while wind blows arrows off course. This makes it more difficult for everyone to shoot. Hence, it is important to limit archery contests to specific environmental conditions. The fourth rule asserts that each archer must stand 20 metres from the target. Standing closer to the target will make it easier for them to aim and hit the bullseye. Therefore, we can only reach fair conclusions if all archers stand at the 20-metre line. Wait a minute, these rules sound like a list of controlled variables. All of these rules must be followed so that we can reach meaningful conclusions about each archer's shooting skill. Similarly, physics experiments must have controlled variables so that we can draw meaningful conclusions about how our independent variable affects our dependent variable. Firstly, we need to use the same measuring instruments each time. This is just like the archery competition, where each person needs to use the same type of bow and shoot at the same type of target. Let's think back to our experiment with a slingshot. We could use a spring gauge to measure the force required to stretch the rubber bands a distance of 14 centimetres. When doing this, we should use the same spring gauge because different instruments might be calibrated differently or have different scales. In other words, we could measure the weight of the same mass using two different spring gauges and get different measurements because their increments are different. Next, we need to keep the environmental conditions the same. As we saw in the archery competition, factors like the wind and rain make it difficult to shoot arrows. Similarly, in physics experiments, we need to keep factors like ambient or surrounding temperature, air pressure, wind speed and light intensity constant, as they may influence results. In our experiment, the range of the pebble would be affected by air resistance and wind. If a strong breeze blows against the pebble, it will slow down and its range will be reduced. To ensure the experiment is valid, we could minimise the effects of wind by performing the experiment indoors. Often, we need to control variables that are specific to our experiment, like how the archers are required to stand 20 metres from the target. For example, when using the slingshot, we kept the launch angle constant by aiming horizontally. If we launched the pebble with the same speed but at a higher angle, its range might have increased. Similarly, the range of the pebble might depend on the size, thickness and material used in the rubber bands. It is likely that thicker rubber bands will increase the range of the pebble. Ultimately, to achieve valid results, we needed to keep many factors constant, including the launch angle and type of rubber band. Do you study any other science subjects, such as chemistry or biology? If so, the core ideas of independent, dependent, and controlled variables are the same across all science subjects. The only differences between the subjects are the experiments you perform, so we will look at different examples in each video. If you study biology, make sure to watch our second lesson on validity for biology, as we will introduce confounding variables. These are variables that are not controlled and may affect both the independent and dependent variables, possibly leading to an incorrect conclusion. In physics and chemistry, you don't need to learn about confounding variables, so we haven't included them in this lesson. Let's revise what we've learned in this lesson. Validity refers to how well an experimental procedure tests the aim and hypothesis of the experiment. A valid experiment is one with a proper treatment of the independent, dependent, and controlled variables. The independent variable is the factor which we manipulate or change in an experiment. The dependent variable is the factor that we measure in an experiment. A controlled variable is a factor that is kept constant in an experiment. The aim of a science experiment is to see how changing the independent variable affects the dependent variable. An experiment should only have one independent variable and one or more dependent variables. All other variables should be kept constant so that we are certain that the independent variable is the only factor that causes the observed change in the dependent variable. We hope you enjoyed this Schooling Online production. For more easy lessons on physics, check out our second video on validity.